Welcome back to Let's Make a Game, the channel where we are making a computer role-playing game using the free program Twine and the SugarCube format for Twine. I want to take a bit of a break from the game that I'm making to show you a couple of potentially useful processes that you can perform using commands that we've already discussed. And the first one is swapping the value of two variables, and the other one is putting a large number of variables, specifically a large number of variables that are in an array, in the same array, into numerical order. So let's look at swapping first. You might do this, for example, I'll just zoom in as usual. You might do this, perhaps you have a system where you roll, say, strength, and then you roll intelligence. And if strength is higher than intelligence for a particular, let's say for elves, if strength is higher than intelligence, you swap them round. Or for ogres, if intelligence is higher than strength, you swap them round, or something like that. So let's go through what we've got here. It's fairly straightforward. I've got set A equal to 7 and set B equal to 10, and then it will print the values of A and B. And this is the important bit, the command that swaps A and B. And we need a third variable to do this. So we have, and all of these commands are within less than, and to start with, and then greater than signs at the end to indicate that they are commands that come from Twine rather than from another language that Twine is using, like JavaScript or HTML. But the first one is we set $x equal to $a. So x is the third variable that we're using. It has to be like a temporary variable that isn't used for anything else other than temporary operations. And it doesn't. I'm setting x equal to a, but it wouldn't matter if you did it the other way around. The difference between a and b, this doesn't require that b is higher than a or vice versa. So we set $x equal to $a. The next command is we set $a equal to $b, and then we set $b equal to $x. And if we do that in that order, then A should have what was previously the value of B, and B should have the previous value of what was A. In other words, they should have swapped. And just to prove that, at the end there I've got two statements that print out what the value of A is now and what the value of B is now. So let's give it a test. And as we can see, it tells us A is 7 and B is 10, and then after the swap, A is 10 and B is 7. So it has done what it promised to do. So let's look at something that's a little more elaborate. Let's say you were rolling 3 dice and you wanted to find the middle numeric value. So for example, if you rolled, let's say, a 2, a 1, and a 6, you would put them in numerical order, 1, 2, 6, and then find the middle value, which is, in this case, 2. Or let's say you were programming a game like Risk, where you roll dice and your opponent rolls dice and you compare them in numerical order. Let's have a look at this. Now sorting things into order is an element of maths and computer science that there's been a huge amount of thought put into, and so the algorithm that I'm going to give you is not it's not like the most efficient one by any means, but it'll be fine for most purposes. So let's go through what we're doing, and once again, all of these commands have the less than to start with, and they end with a greater than. because they're twine commands. So we set $A equal to square brackets, unsquare brackets. In other words, we set up an array called A. Set $N equal to 10. N is just the number of items that are going to be in the array. I have a for loop. Sorry. For $Z equals 1, semicolon, $Z is under or equal to $N, semicolon, $Z plus plus. And then on the next line, set $A square bracket, $Z n square bracket equals random bracket 1, 100 n bracket. In other words, and then we have /4 at the end. In other words, go through every value from 1 to n, which in this case is going to be 10, and the corresponding slot in the A array, give it a random value from 1 to 100. And then print the array. We have a very similar for loop. For z equals 1, semicolon, z for $Z equals 1, semicolon, $Z is under or equal to $N, semicolon, $Z plus plus, print $A, square bracket, $Z, n square bracket, plus, quote, less than BR, greater than, quote. That BR being a line break, the equivalent of entering enter or return. So on this page, and then we have a link, square bracket, continue, vertical line, sort, n square bracket. So what we would expect to see from this is 10 numbers between 1 and 100 inclusive, printed in no particular order, and then a link to which says continue, and which if clicked will take us to the sort page. So let's check if that's right. Yep, simple. Okay, so that bit's working. So let's get to the actual sorting algorithm. So what we have here is a for loop inside another for loop. Again, everything's within less than to start with and greater than to end with. So we have for $Z equals 1, semicolon, $Z is less than $N, semicolon. I've actually put a space there that doesn't actually matter, but that's more how it should be. So for $Z equals 1, semicolon, $Z is less than $N, semicolon, $Z plus plus. So that's going to go from 1 to, in this case, N minus 1, because you notice normally you would expect to see $Z is less than or equal to $N, but this time I've put $Z is less than $N. So it's only going from 1 to N minus 1, in other words, from 1 to 9. And then we have another for loop, the beginning of another for loop. We have for $Y equals Z plus 1, semicolon, $Y is under or equal to $N, semicolon, $Y plus plus. So that's why this first, that's why we've got $Z is under $N, not $Z is under or equal to $N, because Y starts as Z plus 1, and if Z went all the way up to N, well then Y would start at N plus 1, and we don't want to go higher than N, of course. N is the number of things that we're dealing with. So that's why we do that. So what these two loops between them are going to do is compare every pair of slots in the array is going to be compared. So it'll compare 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, all the way up to 110. Then it'll go 2, 3, 2, 4, 2, 5, 2, 6, up to 210, then 3, 4, 3, 5, 3, 6, etc., all the way up to comparing 9 and 10. So, and this is the sort of most important part, and this is the part, it uses a very similar process of swapping as we saw in the previous program. So if $A square bracket $Z n square bracket is greater than $A square bracket $Y in square bracket, then we do three different things. We set X equal to, or set $x equal to $a square bracket $z n square bracket, set $a square bracket z n square bracket equal to $a square bracket $y n square bracket, and then set $a square bracket $y n square bracket equal to $x. So we're doing the same thing that we did with a, b, and x in the other program, which was we set x, which is just a temporary variable, set x equal to az, set az equal to ay, and set ay equal to x. In other words, if az is greater than ay, well, it shouldn't be that way. It should be the other way because we want them in ascending order. So swap them. And then after those three commands, we just have /if, /for, and /for to end the loops. And then finally, we print the array, and this is identical to how it was on the previous page. So it's for $z equals 1, $z is less than or equal to $n, $z plus plus, print $a, $z plus a line break. So what that will give us, if this process works, is the same numbers as we randomly generated, but now sorted into ascending numerical order. If we wanted them to be in descending numerical order, we just change the sign. So instead of if $a square bracket $z n square bracket is greater than $a square bracket $y n square bracket, it would be if either if ay is over az or if az is less than ay. So let's see if all of that works. So now we can look at this and we can sort of predict if this works. We should see, in this particular case, 12, the first one generated is actually the lowest. So it should start with 12, then 18, and then looks like 33 and 35, and then it should end with looks like 81 and 98. So let's see what we get. 12, 18, 33, 35, and it ends with 81 and 98. And if we go through that, we will see that that is actually in ascending numerical order. So obviously that works. So I hope that those two things were useful or interesting to at least some of you. Probably the swapping one you'll be doing more often, but the putting things in a numerical order, you might find that that's useful for your game as well. Another use I just thought of is if you have a list of scores, for example, and you want to put them in order, you could sort the array, and then if you were sorting, you could have, say, one array that was the scores and one array was the person that got the score, and every time you swapped two elements in the score array, you would swap the corresponding elements in the name array, and that way you'd end up with an ascending list of scores and then another array with the people that got those particular scores. But for whatever reason, I hope you find some reason to use that, and I hope you will tune in next time.